Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part of video, I would like to explain or teach what is the impulsive and what is the impulsive force and how we can understand impulsive force with help of some suitable examples from the chapter of laws of motion. Impulsive. Impulsive is nothing but the product of force and time is called impulsive. So listen very carefully. The product of force and time is called impulsive. Impulsive is represented or denoted by the symbol of J. J is equals to F into T. F into T. F is the force, applied force, and T is the time interval. That's why this is the formula of which one? Impulsive. The product of the force and the time is called impulsive. But what is the impulsive force? That is also discussed. A large force which acts on a body in a short interval of time. Listen very carefully. A large force which acts on a body in a short interval of time. That force is called impulsive force. That force is called impulsive force. So this is very important for us. A large force which acts on a body in a short interval of time, that force is called impulsive force. F is equals to J upon T because we know that impulsive J is equals to F into T, then F is equals to J upon T. Now we derive the relation between impulsive force and time. So impulsive force inversely proportional to the time interval or the time acting on that body. Listen very carefully. Here F is the force and T is the time. The product of force and the time we are called impulsive. Impulsive force means a large force is acting on a body in a short interval of time, that is called impulsive force. But the impulsive force is mainly depend on time factor. That's why how the impulsive force is depend on the time factor means based on this impulse formula we can say that clearly. F is inversely proportional to the time. Means impulsive force is inversely proportional to the time. Is really it is correct or not? We are discussing that. Is nothing but if time of action is less, more impulsive force is acting. If time of action is more, less impulsive force is acting on the body. Is it correct or not? We are discussed with help of some suitable examples in this time. And before going to that, impulsive force or impulse is all equals to the change in momentum. Is nothing but the units of impulse or impulsive force and change in the momentum units both are same. So means is really correct or not? We are discussing that. F is equals to, we know that ma. So that is equals to m into a means acceleration v minus u upon t. Is it correct or not? That's why this t transfer to this side. Maybe we can write like this one step by step. So according to the Newton's second law, F is equals to ma. So m into v minus u upon t. T transfer to the left hand side. Ft is equals to m into v minus u. Ft is nothing but j, that is equals to m of v minus u. So that's why what we know that the product of force and time is called impulsive, that is the j, is equals to m of v minus u is nothing but it is the change in momentum. That's why so the impulsive is always equal to the which one? Change in momentum produced by the force. The impulsive is always equal to the change in momentum produced by the force. This relation is very, very important. Momentum is, so change in momentum is equals to dash, which one? Impulse. Impulse is equals to dash in the following change in momentum. So now we discuss some suitable examples for understanding the which one? Impulsive force. So first one, simply we discussed one thing. So during cricket match, you are observing that most of the students are fan of cricket match. When the cricket match is running in a ground, you are observing that just we are assuming a batsman will be hit the ball into the sixes or stands. Is nothing but so the bowler will be firstly come, either it is the spin or it is the fast bowling. So he will be thrown the ball towards the batsman. Now the batsman will be hit the ball with the help of the bat. So you are observing that the ball will be goes to the stands. Stands is nothing but from the position of the batsman, the stand will be so many meter distance is there, nearly 90, 100 meters like that one is there. Means so you are observing that so how much time of action will be there here? You are observing that means when here you are observing that the ball will be comes towards the batsman, then the batsman will be hit the ball in this one. So the time of contact between the ball and the surface of the bat is less. Means so in the short interval of time, a large force is acting on the cricket ball by the bat. That's why the ball will be goes to longer distance or onto the stands, we can say. And second one is we are observing that one. This example we are observing in your daily life. At any one of the time also you are also feel that one directly also. What is that one means? When you are moving when you are in a bus, you are the one of the passenger in a moving bus. You are sit in the seat at the last row of the bus. So in the last row of the bus you are sitting, you are in sitting position. The driver was, due to any one of the reason, he was unable to see the speed breaker on the road in front of him. So by any one of the reason, he crosses the speed breaker with 50 kilometers per hour. You are observing that, okay, when the driver was crosses the speed breaker with 50 kilometers per hour, with due to any one of the reason, the passengers which are sitting already on the last row of the bus, they jump from their positions. And some of the cases, our head will be touches to the roof of the bus also. Is it correct or not? So how it is possible? Generally, if the bus will be moving with the same 50 kilometers per hour on the even road, okay, if by yourself you try to jump without using your legs on the floor and from the seat directly you can try to jump, it is not possible. But here, why? Because of on you gravitational force is acting. So if you can stand up on the, okay, from sitting to standing, you must be apply some force on the floor of the bus with help of your force, because of you, when you are apply some force opposite to the gravitational force, then you can stand. But here you are not apply the any force opposite to the gravitational force, but okay, from your sitting position to you are jump up to the certain height, means what is meaning? A large force is acting on you within the short time, because of a 50 kilometer fast moving bus is crosses the speed breaker. How much time is taken? Less than the 1 second. In the less than the 1 second or millisecond, so large force is acting on the passengers, those are sit on the last row. That's why the passengers will be jumped. That is also one of the best example for the which one? Impulsive force. So what is the first one means to discussing that in a cricket match, the batsman will pick the ball will goes to the stand. At that time, a large force is acting on the ball in the short interval of time. Next one here is also, okay, second one. The passengers, those are sit at the last row in a fast moving bus. If the bus will be crosses a speed breaker with that much of speed, the passengers at the last row, they jumps and their head will be maybe touches to the floor of the bus, so roof of the bus. Next, one more thing is also discussing there. This example is also very important for the exam point of view in 9th standard level in the chapter of laws of motion. What is that one means? An egg we dropped from 1 meter height from the rigid surface. An egg it is dropped onto the hard floor from 1 meter height. What you are observing that when you can drop it from 1 meter height, so when the egg will touches to the hard floor, immediately it will be broken. So here the same, okay, we can take another egg. The another egg will be also, we can release it onto the soft cushion pillow which is already placed on the hard floor. Means on the hard floor we place it on a cushion pillow here, and the egg is dropped from the 1 meter height from the pillow. At that time, when the egg will be fall onto the pillow, you are observing that it may not be broken mostly. So why here when the egg will be touches to the hard floor, here it is broken, but here it may not be broken. What is the reason? Here both cases the egg will be released from how much height? 1 meter height. But here egg is broken, but here egg is not broken. What is the reason? Means in this one impulsive force will be involved. How the impulsive force will be involved? I say that F is inversely proportional to the time factor. Is nothing but so impulsive force is inversely proportional to the time of action. So in this one, when the egg will be dropped onto the hard floor, when the egg will be touched to the hard floor, so the egg is just touched to the hard floor during the falling. The time of contact or the time of action between them is very less. But when the egg is just touches to the floor, immediately it will be broken. Is nothing but it means the time of action between the time of contact of the egg and the floor will be very less. That's why so more force is acting because of time of action is less, more impulsive force acting on the egg by the floor. That's why egg will be broken. But here, okay, so the egg will be not directly contacting which one? Hard floor. It will be fall onto the cushion pillow. The cushion pillow will be slowly compressed. Means the egg is directly not directly touches to the hard floor. Before touches to this one, the egg will be fall onto the cushion pillow and slowly come to the downward by compression of the cushion pillow. That's why the time of action is increases. When the time of action is increases or the time of contact is increases, then impulsive force will be less. Listen very carefully. The egg will be fall onto the hard floor. The egg will be broken because of the time of contact. The time of action between the egg and the hard floor is less. That's why more impulsive force is acting on the egg by the hard floor. That's why egg will be broken. But in case of the cushion pillow, egg will be fall onto the cushion pillow. It is not directly touched to the hard floor. That's why when it will be fall onto the pillow, so the pillow will be slowly compressed. The egg is also slowly comes to align with the pillow. That's why the time of action or the time of contact is increases between the egg and the hard floor. That's why if the time of action is increases, then impulsive force will be decreases. That's why the egg may not be broken. And one more thing, shock absorbers are fitted for the vehicles. You know that, okay, for every vehicle, shock absorbers are there. Mostly in case of, okay, two-wheelers, in four-wheelers is also there. But in the two-wheelers, clearly we are seeing at the rear wheel, okay, from the rear wheel to, okay, for the pylon-guided seat, you are observing that one spiral spring like that structure is appeared in the rod. That is called shock absorbers. Why the shock absorbers are used means to reduce the impulsive force is acting on you when you travel on the uneven road. So listen very carefully. In this part video we discussed that what is the impulsive, what is the impulse force, and impulsive force is equals to the which physical quantity, and what are the example to understand impulsive force nature. Impulse is nothing but the product of force and time is called impulse. Impulsive force is nothing but a large force which is act on a body in a short interval of time, that is called impulsive force. Impulsive force is inversely proportional to the time factor. Impulsive is a vector quantity because of impulsive is nothing but it is in the direction of the force. Force is a which one? Vector quantity. That's why impulsive is also a vector quantity. But impulsive is equal to which one? Change in momentum. So from the Newton's second law of motion, F is equals to ma. From that formula, we can clearly prove that or derive. So Ft is equals to m of v minus u is nothing but impulsive is equals to change in momentum. And what are the example to understand the impulsive force means in case of a fast moving bus, the passengers at the last throw, those are sitting, they feel impulsive force is acting on them. If the bus will be crosses a speed breaker or uneven with a certain speed. Next one, during playing a cricket match, the batsman is hit the ball. If the ball will goes to the stands during the 4 or 6, at that time a large force is acting on the ball in the short intervals of time. So next one, an egg will be fall onto the hard floor, it may be it will be broken. If it fall onto the cushion pillow, it may not be broken. And one more thing is also, they are asking that one thing. If a person is jumped from tall building, here a person is there, just we consider here. So the height, okay, one building we are considered that this height of the building is h. This is also same h, because of same building we consider that. One person will be jumped onto the hard floor. You are observing that maybe he injured. Is it correct or not? A person is jumping onto the hard floor from the top, okay, roof of the house. He may be injured. But same person will be jump onto the hard floor, okay, but not the hard floor. He jump onto the heap of sand. Heap of sand. Heap of sand means the sand is like this one is there. If the same person is jump onto the heap of the sand, okay, he may not injure. Is it correct or not? A person is jumps onto the hard floor from the height of the building, he may be injured. But the same person is jump onto the heap of the sand from the same height of the building, he may not injure. What is the reason? If he fall onto the hard floor, the time of action or the time of contact between his body parts and the floor is less. That's why more impulsive force is acting on the person by the hard floor. But when he jump onto the sand, okay, heap of the sand, when he fall onto the sand will be heals and the person will be slowly comes to the down. In this time, what will happen? The time of contact or the time of action is increases to reach the person into the hard floor. That's why time of contact is increases, impulsive force will be decreases. That's why the person may not be injured. This is also one of the best evidence to us to understanding the impulsive force.